Hey guys, we've got chapter 33, number 58 here. We're talking about two parallel plates. We've got an electron moving through these parallel plates with some velocity, and the question is asking what's the forces that are going to be on it so that it can make it through without being deflected in any direction. So we know there's going to be an electric force on it, and we know there's going to be a magnetic force on it, and ultimately there's going to be F net equals 0 because there's no net deflection. So we've got that up in the top right corner there. F net equals 0, so F electric plus F magnetic. Those forces are going to sum to equal 0. And so now we can get on with the problem. We can start by solving for the electric field, ultimately solve for the force, the electric force. So we'll solve here. We're given that they're charged plates, 200 volts. Is the potential difference across them. So V equals ED. We solve through. We get electric field is 20,000 volts per meter. Then we move on to the force equals negative QE. We plug in the E that we just solved for, the charge of an electron, and we get the electric force here is 3.2 times 10 to the negative 15 newtons up in the up direction. We can confirm this up direction using the right hand rule. It's going to be a little hard here from above, but index finger in the direction of velocity, thumb in the direction of the force of the electric field, and your middle finger, which is hanging down here, is going to be pointing down into the board. So we see the X's here as representation of that. So now we have the force of the electric is going up. We know that because F net is going to need to equal 0, then the magnetic force needs to be going down in order for there to be no net deflection on this electron as it passes through. So in order to do so, we'll say that F magnetic here, we'll call it as negative 3.2 times 10 to the negative 15, just to take care of that down direction. And we know there's a relationship here that F magnetic equals QV cross B, and this cross product, if you go back to the picture, is right here. We can take care of it. It incorporates a sine of an angle. That angle is the velocity vector, and the B field, it's a 90-degree angle there, and because of that, sine of 90 is 1. So we can say force equals QVB. So that's basically saying this. I've already pulled out the B, but B equals F over QV. Well, we know F needs to be negative 3.2 times 10 to the negative 15, and we have our charge again of our electron, and we have the velocity of this electron as well. It looks like this should be 1.6, not 1.1, times 10 to the negative 19 for that charge of the electron. And when we solve out here, we get that the B field required for the electron to make it through needs to be 2 milliteslas, 2 times 10 to the negative 3 teslas, so that it can make it through without being deflected. And that is it for chapter 33, number 58. Thank you.